All right, so my name is Alicia Kaysen. This is for um, 3. Project 4. I do apologize for threads. So we're going to start with our contender class. Okay, so the contender class represents a participant in the battle. Each contender runs its own thread, so implements the runnable interface. So the first thing we have is import java.until.random. This imports the random class to generate random rest times. I do apologize ahead of time. I have a lot of notes within this one just because it was a little tougher to wrap my head around. So we have the pilot class contender implements runnable. So each contender runs in its own thread, so it implements the runnable interface. So we have that runnable implements right here, implemented right here. We got private int action unit, the number of sprints the contender competes in one burst in actions. Then next we have private int concurrent total, the total number of sprints completed so far. Private int max rest time, the maximum time in milliseconds the contender will rest between actions. Private water source, the shared water object for synchronized access to water breaks. Private int drink rest time, the amount of time in milliseconds the specific contender rests while drinking. And I do apologize, I'm not sure if I said private string name, the contender's name at the top. So a shared static flag to signal the battle is over. Volatile ensures all threads see the most recent value. So we have it here, public static. Volatile boolean, winner declared equals false. All right, so we have the constructor for the contenders. And this is just some names, but the constructors down here. We have public contender. In our arguments, we're going to have the name, action unit, max rest time, water source, and drink rest time. We're going to implement the this dot name, this dot action unit, this dot current total equals 0. That starts the total completed sprints at 0. This dot maximum rest time, max rest time, this dot water source, and this dot rest time. So the core battle logic, this method runs when the thread associated with the contender starts. So you have that override. Public void run, random equals new random. Object used to generate random rest durations. The battle continues until the winner declared flag is set to true by any thread. Now we also want to do some exception handling. So I do have a while loop here for that winner declared. And like I said, that exception handling starts here with our try. And within that, we have the contender rest, thread sleeps for a random duration up to max rest time. So we have int rest duration equals random. So that way we can have that random duration. Dot next int max rest time plus 1. It's going to print out the name of the contender. It's resting for. It's going to give us the rest duration, and which is in milliseconds, hence the ms. All right, we're also going to put this thread to sleep. So thread.sleep rest duration puts the thread to sleep for the rest duration. 2, we're going to perform the action. We're going to increase the total sprints by the action unit. Current total plus it equals action unit. 3, we're going to print the contender's name and current total sprints. So the name of the contender has completed current total, and it's going to say how many sprints. We're going to take a synchronized water break by calling that drink method on the shared water object. So we have water source dot drink, name, drink rest time. 5, we're going to check if the contender has completed 200 or more sprints. So we're going to do an if statement here, current total greater than or equal to 200. We're going to use a synchronized block to ensure only one thread can declare the winner. And update the shared flag, preventing race conditions. So we have that synchronized right here. Contender.class, because we only want one contender, we don't want two, we don't want it two, recipients. So we have that double check inside the synchronized block to confirm no one else won just before. We have this if statement, winner declared. Winner declared equals true. Sets the thread shared flag to end the battle for all contenders. And once it that, we're going to have a printout statement. Battle is over. Name of that winner is the ultimate winner with. It's going to give the current total of sprints. All right, so we have a break here, and that's going to exit the main loop. Sorry about that. We also have a catch block here. And we're going to catch the interrupted exception. And we're going to end with E. And this handles the exception if the thread is interrupted while resting or drinking. And it's going to print out if we do have an interruption. Was interrupted, resting / drinking. It's going to say the contender's name first. We have thread.current thread.interrupted. It reinterrupts the thread status flag. We have that break. It exits the loops if it's interrupted. The final message indicating the thread has completed execution. It's going to print out has the contender's name has finished their battle part in the battle. Right? We're going to move on to our water class. So the water class acts as a shared resource, a single water fountain for the contenders. It uses synchronized methods to manage concurrent access. So we have public class water. The synchronized method allows only one contender to drink water at a time. The synchronized keyword locks this method, forcing one thread to wait. So we don't want them both drinking at the same time. We want them at one another. So we got that public synchronized void drinks. And we're going to put in our arguments the contender name and the rest time. We're also going to do some exception handling here inside our water class as well. We're going to print out a little space. The contender's name is starting to drink 4. And then we're going to get the rest time in milliseconds. We're also going to put the thread to sleep here. Puts the thread to sleep, simulating the drinking situation. Our catch block, which is the same as the other one in the contender. Interrupt the exception, E. And it has the exception if the thread is interrupted while it is sleeping. And if it is, we're going to print out that print statement with the contender name, was interrupted while drinking. So we're going to go to our Ultimate Battle app. Right? So the program stimulates a battle between two characters using our Java threads. It demonstrates concurrent execution, shared static data, and uses of synchronized methods to control access to a shared resource. So the two contenders that I have chosen is the Flash and Quicksilver. It's the race to compete 200 sprints. Each runs in its own thread, resting, performing the action, and taking a water break. The water break uses a synchronized method, ensuring only one contender can drink at a time. The first contender to reach 200 sprints wins the battle. So I am doing a little bit of hard coding, so I have no user input in this one. So we're going to start with public class, Ultimate Battle app. It's going to be our main. In the beginning, we're going to have the Ultimate Battle begins, right? We're going to create one instance of the water class to be shared. The single instance is necessary to enforce synchronized access to the drink method. So this is in order so that the contender can access that drink method. So we got water, shared water source equals new water. We're going to create the two contender objects with their unique battle perimeters. Okay. So for the Flash, we're going to have contender Flash equals new contender. He has a higher action rate with 15 sprints, longer maximum rest times, but a quicker water break. And we have this all instantiated here. So we have the Flash, 15 action unit, max rest time 400. We have that shared water source, and then we have drink rest time at 100. Right? We're also going to create a new object for Quicksilver as well. And our Quicksilver has a lower action rate, shorter maximum rest times, but a longer, more costly water break. So we essentiated that here. As you can see, we have Quicksilver as the name, action unit 8, max rest time 200, shared water source, and then drink rest time 300. Right? We're going to create the two thread objects, each containing one of the contender instances. So we have thread, flash thread equals new thread, flash, thread Quicksilver thread equals new thread Quicksilver. Right? We're going to ensure that the threads are user threads, the default, meaning that the JVM must wait for them to finish before shutting down. So flash.thread.set daemon false, Quicksilver thread.set daemon false, because we don't want it to shut down before it finishes. We want both to finish, not just one finishing it in the program. All right. So we're going to start the execution of the threads, invoking the run method for both and contenders simultaneously or concurrently. So as you can see, we're starting here, flash.start, Quicksilver thread.start. So we're starting those threads. And we're going to do some exception handling here as well. So pauses the main thread until both contender threads have completed, finish their run method. Excuse me. So we're going to put in our try, flash thread.join, Quicksilver thread.join. We also have our catch block here as well. Interrupt exceptions, handles interruptions to the main thread while it is waiting for the battle to end. If it does interrupt it, we're going to have it print out main thread interrupted while waiting for contenders. Right? Then we have that thread.concurrent thread interrupted. All right. But if we're able to catch everything and everything's good, what's going to happen is it's going to print out the statement that the ultimate battle has concluded. So we're going to go ahead and pull this up here, and we're going to go ahead and run our program here. We're just waiting. And it's going pretty fast, but you see that they're both going concurrently. Flash and Quicksilver, they are racing their sprints. And the battle's over. The Flash is the ultimate winner with 210 sprints. And in the end, it says the Flash has finished their part in the battle. Quicksilver has completed 120 sprints. Quicksilver is starting to drink water for 300. Quicksilver has finished drinking water. Quicksilver has finished the part in the battle. And then it says the ultimate battle has concluded. So as we ran the program, we've seen that how they were running together. It's a lot. We see how the Flash is starting to drink water, and how it lets him finish drinking water first, and then it does. Quicksilver has completed their sprints, and every time Quicksilver drinks water, it pauses and so on. So I hope this was a good demonstration of threads, or a good explanation of code for my threads project 4.